All right, geometry, we are on Unit 4, Quadrilaterals. So we started the year off talking about single lines, and then we were talking about lines that intersect, and then we started talking about lines with three sides, and we call those triangles. If we have a figure that has four sides, that's called a quadrilateral. So these are the properties of quadrilaterals. So a quadrilateral is a figure with four sides. Oops. A figure with four sides. So I have a bunch of quadrilaterals listed here. We'll save the properties. Well, you can write everything down here. Take a minute, pause this, get these written down, and then I will go over them once we have everything written down. So just take a minute and pause it. All right, so we got everything written down. First of all, we've got a parallelogram. Parallelogram is going to be a figure that has two pairs of parallel sides. So the opposite sides are parallel. Notice there's two arrows on that one, and there's one arrow on this one. It's kind of the same as congruence. When there's two lines, those match up. When the arrows are the same number, those lines would be parallel. So a quadrilateral with two pairs of opposite sides being parallel. And then we have special types of parallelograms. We have a rhombus, and that's kind of what a rhombus can look like. Maybe tilted a little bit, but all four sides are congruent. Next is a rectangle. A rectangle has four right angles, not necessarily all congruent sides, but we do know the opposite sides are congruent, and those sides are congruent. So the special thing about rectangles is that it has four right angles. And then we have a square. I know we all know what a square is, but to define it, it is a quadrilateral, a parallelogram that has four congruent sides and four right angles. So the big question is a square a rectangle? Is a rectangle a square? Is a rhombus a square? Is a square a rhombus? And we're going to end up drawing a Venn diagram to show when these particular situations happen. So next we get into, these are all parallelograms here. So these ones are all parallelograms. Don't have space to write that. We'll just draw kind of a line here. Then we get into a trapezoid. A trapezoid is not a parallelogram. It is a quadrilateral, but it does not have two pairs of opposite parallel sides. It only has one pair of parallel sides. So the other two sides are not parallel, and we're going to get a little bit deeper into trapezoid as well. So we have special kinds of trapezoids called isosceles trapezoids, kind of like an isosceles triangle. It has two congruent sides. An isosceles trapezoid also has two congruent sides, and then it's two pairs of it's pair of parallel lines as well. In isosceles trapezoids, there's some special properties. We know that the legs are congruent, which we're going to get into what part the legs are. The base angles are congruent, and the diagonals are congruent. And I'll explain all of that in just a minute as well. And the last one that we have is a kite. A kite has two pairs of congruent sides, however, they are adjacent. So notice the two sides that are congruent touch each other. So it has two pair of congruent sides that are adjacent. That is a kite. Next are the properties of parallelograms. Remember again, these are our parallelograms here. So we've got the opposite sides are always parallel. The opposite sides are always congruent. The opposite angles are always congruent. Consecutive angles, the two angles that touch each other, are going to be supplementary. They're going to add up to 180 degrees. The diagonals, which we'll talk about in a second, bisect each other. That means that they cut them in half. And then last, if one angle in a parallelogram is 90 degrees, then we know all four angles in a parallelogram are 90 degrees. So that is what we've talked about so far. A few more things before I let you go. We're going to take this Venn diagram here and change a little bit, but we're going to go off to the side and draw a different one so we have a little bit more room. So I want you to draw two circles. If you remember what a Venn diagram is, we're going to compare and contrast. You maybe use this in English class. A Venn diagram. So this is a diagram of parallelograms. Change colors. Parallelogram. So these are all of our parallelograms. So in one of our circles, we're going to write rhombus. And we remind ourselves a rhombus has four congruent sides. And then maybe we can draw a few rhombuses to remind ourselves what they look like. They can look like that, they can look like that. So those are our rhombuses. So that's going to be, let's make that our yellow circle. So everything inside the yellow circle is a rhombus. And then we've got, let's make this one a blue circle. Everything inside the blue circle is going to be a rectangle. And remember, a rectangle has four right angles. So we can draw a few rectangles here to remind ourselves what those look like. They can be skinny or they can be bigger and fatter like this. But they're always going to have four right angles. And then we notice we have this overlap here. So this would be both a rhombus and a rectangle. And what do you suppose we're going to draw inside of that? That is where our square goes, because a square has four congruent sides and it also has four right angles. So a square can be a rectangle, a square can be a rhombus. However, a rectangle is not a square and a rhombus is not a square. So squares can be either one, but rectangles and rhombuses are their own. So there's our Venn diagram. I want to talk about trapezoids a little bit here. So there's some special properties of, or not properties, but parts of trapezoids that we need to know about. So I've got my trapezoid here. Sorry, my lines aren't very straight. We've got what we call legs. The legs of the trapezoid are the two sides that are not parallel. Two sides not parallel. So they're opposite of each other, but they're not parallel. The sides that are parallel are called our bases. So that's a base and that's a base. And then the last part of a trapezoid I want to talk about, if we find the midpoint here and the midpoint here and we were to draw a segment just like in a triangle, we also have the mid segment of a trapezoid. In order to find the mid segment of a trapezoid, we would take the average length of the bases. Average length of bases. So we would add them together and divide by 2 because we have 2 bases. So those are the parts of a trapezoid. Hopefully in your mind, you're seeing where algebra is going to end up coming into this. If we know sides are congruent, well, we have equations. We set them equal to each other. If they're supplementary, we're going to add them together and set them equal to 180 degrees. So we'll end up talking more about algebra next week. We're just laying the foundation this week for what quadrilaterals are and their different properties. So that, I believe, is all that I have for you on this lesson. Next week, we're going to bring in some algebra and solve some of these. Let me know if you have any questions. Otherwise, study up for your test next week. And that's all.